Well, hey everybody, just a couple of new interesting developments. I added this assignment, which is related to joining and data and symbolizing the results. So as of today, which is March 24th, Johns Hopkins put up some countywide data in the United States at least. So this will be interesting for our U.S. friends. So it's related to the COVID-19. The data hygiene isn't perfect, and we're going to deal with that in a moment. But that's where GIS can really come into play and sort of help things out in putting this together and visualizing some of this data. So what I want to do is grab some of that data. Now, again, I have to give a shout out to ESRI, who's been they've been at the forefront of providing all of us with great resources all around the world. So I really want to thank ESRI for all that they're doing. You can download the data from this link. And if we click on this link, it's going to take me now, here we go, to the ESRI site. And this is the COVID-19, but this is the countywide data. Now, these are points. And what I can do is just scroll down, and you can see this is the URL. We're going to copy that in a moment. But the other thing I wanted to show you is we can also download census data. So this is the census boundary file that you'll see in just a moment. So this is the cartographic boundary files for the census, and I am interested in grabbing the county boundaries. We can get the one here that's we'll get the middle one, right? So I don't need all that detail, but let's get the county boundary. So this will download. I'm going to show you how quickly this sort of comes together. So here's all the data. I can copy this, and I'm going to paste it into my ctemp QGIS lab directory. So I've done that, and then I pasted it in here already. So inside of QGIS, I'm just going to grab my shapefile. Let's find the boundary. Here it is. Just drag that in, and we'll say OK. So these are my county boundaries. Let's zoom in a little closer to here. Great. Well, again, back in the ESRI site that's linking to the services, I'm going to copy this, and we'll go back into QGIS, and I'm going to add a layer, and let's add a feature service because ESRI is storing it that way. And I've already got this, but let's click on edit. You would click on new, so it's county void, and what I'm doing is I'm pasting what I just put in there. Let's connect to it, and there are cases. Let's add those, and you can see all the cases being shown. Now these are all the county centroids. Let's zoom in a little closer. And these are being streamed over the internet. So you're free to right click and then export that data if you want. I'm going to just happen to use it live. I just think it's kind of cool to do that. But again, for your own personal use, maybe you just want to make it local. Now the good thing is ESRI has done a good job of doing some cleanup here. So if you click on this, you can see the FIPS code for the actual county is here in Litchfield, Connecticut is 09005. And if I click on the polygon for that same area, I've got 09005. So you can join it in that way if you want, just based on the attribute. So because I want to do some more manipulation a little bit later on, I'm going to just go under Vector, Data Management Tools, and Join Attributes by Location. So again, those of you who've used the ESRI product know this is more like a spatial join. So the input layer is going to be our counties. The join layer is going to be that layer 0. We should have named it cases, but that's okay. And we'll use the contains clause, so where this polygon contains the point, which you see what we have here. And we'll take it from the first feature. And I'm going to create a temporary layer. Right? There's other things that we can do, but we'll just run this for now. So let's let this go. And it's almost done. There it is. So that's done. Told me it was completed. I'll close this. And now when I click on this joined layer, let's look at Suffolk County, New York. So now we have Suffolk County, New York, all the attribute information, but we also have information on the number of confirmed cases, the number recovered, the number of deaths, and so on. So now we've linked it. We've linked it live to the coronavirus data that's on the ESRI site. The next thing I just want to do is real quickly, and you guys can play around with this as well. Instead of a single symbol, let's create a graduated symbol, and we can look at how about the number of confirmed cases, and let's classify that. Okay, so you can see what's happened here with equal intervals. This goes back to my other classes that I teach. We have such a high range number here that it's causing a lot of the other counties to be zero. So what I'm going to do is change this to, let's go with quantiles, so an equal count. There we go. So maybe we'll change that a little bit more as well. Probably not using the best color that I have here, so I can probably choose a different kind. Let's use this spectral color, so something like that. So that gives us a little more variability in our colors. Let me do one other one here, and we can also invert the color ramp. So let's look at all the color ramps, and the one I like here is, think about a traffic sign. So red being bad, green being good, yellow being a little more risky. Unfortunately, you can see the green is the high values, so I don't want that. So I'm going to invert the color. There we go. So we can apply that. So again, this is using the quantile breaks, and you can see, let's close this. Actually, if I can come in here and we'll just zoom out. I want to keep this open because I want to play a little bit more with it. So now you get some idea of the numbers of cases that are out there, the confirmed cases. We can also change this and look at the number of deaths. And again, we can classify that. There we go. So pretty much you can see where most of the deaths are occurring. Equal count. Let's look at natural breaks. So that's a little bit different that you can see. So lower numbers here. You can see some higher values here for number of deaths. And then obviously somewhere in New York, we're seeing a lot more deaths occurring in this area. Let's go back to the cases again, or the number of confirmed, and we'll classify that. Instead of natural breaks, why don't we choose, I want to keep it with natural breaks. Just classify that again. There we go. So this again is another map we can look at and get some general idea of the level of intensity. We've been hearing a lot on the news, obviously, about Westchester County. And here you can see Westchester County, and here's Manhattan as well. So these are where those hotspot areas are. Another thing I want to do real quick is go into my plugins, and I want to manage and install plugins. And I just typed in Visualist. You can do the same. So this is a new plugin from QGIS. You've already learned about those, and this is for performing. They mostly set it up for crime analysis, but actually it can be used for any kind of spatial autocorrelation. So you can install that plugin and then follow along with me. So then here we'll click on our toolbox over here, and under Visualist, I have a bunch of different types of things we can do. We can create flow maps. We can create, perform things with spatial statistics as well. And we can perform spatial autocorrelation. So this is going to use the local Moran's eye analysis. So let me double click that, and we're going to use the join layer. We can, for our values, why don't we look at the confirmed cases, and you can use Moran's eye or Geddes org. So we're going to use the Moran's eye, and we'll use a Queen's case, right, in terms of who is near one another. I'm going to run that real quickly, and we'll let this finish off. Oh, actually, it already did finish. So let me close this, and we'll expand our values. So let's zoom out. So we can see some of the LISA coordination. So areas that are very low are in blue. In fact, if we click on, let's say Monroe County here up in New York, let's get a little bit closer so I can see it. And then if I click on Monroe County, you Okay, we can see the local Moran's Eye, and we can also see some of the relationships they have. There's a high to a low join here in terms of its categorization. So I have some areas that are higher and lower. Let's zoom back again, and let's zoom into the New York area. So right here, let's click on Westchester County. And in Westchester County, what we see is a high. So this is an area that is near other high areas. So you can see the spatial autocorrelation that's occurring. So these are extremely high values here in terms of the number of cases. So let's zoom out a little bit more. There we go. Let's make this smaller too. So now you can start to see, at least in terms of spatial autocorrelation, where areas that are near one another are similar. And here, look, throughout the US, there's very little autocorrelation. Most everything is just, there's nothing going on for the most part, right? Um, so you can see where our hotspots are actually occurring in terms of their relationships. And again, you can also begin to just look at the number of cases in this fashion as well. But spatial autocorrelation gives us one other way to look. So that shows you how to take some additional tools in QGIS and grab stuff live off the internet, put in some plugins and perform some spatial joins as well as some advanced spatial autocorrelation. So again, your professor might want to have you do some extra type of assignments along with that. I'm going to probably have my students do the same. So enjoy the data and stay safe.